Welcome to All Things Data Science, the one-stop channel to help anyone interested in learning or transitioning to data science. Just like I did. In today's session, we're going to do another problem from the LeetCode series, more particularly the one called rotated digits. It's in the easy category and it's specific to string, though unfortunately it's kind of giving it away by even saying that it's in the category string, and I'll explain why. So here's the problem statement. I have to say this is one of those that is actually not as straightforward in terms of you do need to read it a couple of times to see what they are talking about. So let's dig in. Basically, there's this idea of flipping 180. Keep in mind that they're talking about each digit. So each digit must be rotated. So those are the two very first things I want to start with. So if you have one, and I'll try to pick specific good ones. If you have 1, 8, 9, then you're supposed to flip everyone individually. So that becomes a 1. This becomes an 8, and we'll get to why it is what it is. And this becomes a 6. So each individually. All right, so what's up with all these colorings? Actually, their idea is that 0, 1, and 8, when they rotate with 180, right, they stay themselves. Okay, so let's quickly summarize that. So 1 becomes a 1, 8 becomes an 8. What was the other one? And then the 0 is a 0. I don't think we're going to need to worry about any problems with the leading 0 because it's not going to be an option from the beginning because you can't have a 0, 1, 10 to mean 10. So at least that's something also to take out. Now, then there's this other interesting one, which is the 2 and the 5 and the 6 and the 9. They flip a certain way, like mirroring versus sort of you could flip them in different directions or whatever. But at the end of the day, if you do a 180, they're going to become each other. So that gets as, maybe let's color this as the blue category, and then you have a 6 becomes a 9, a 9 becomes a 6, a 5 becomes a 2 is a 5. So that's this category. So that's what's going on here, period. Now, once we understand this whole flipping business, we could start getting to sort of what I like to call the core of the problem. So that was that. But before we get there, that's not actually what we've just discussed is not what we need at the very end. Let me get creative here with some different colorings. What we want at the end is a count. But a count of what? Well, you're gonna be given as your input this number n. Think of n, like in this case, n is 10. So what does that mean? Very first thing we're talking about, we're gonna look at each x between the number 1 and n, this being your input. So directly, and we don't go at 0, we go at 1. So we've got 1, 2, 3, all the way to n, and n can be up to 10,000. So then our job is to loop individually through each and say, you know, is it good? In this particular case, it's actually not good. So now we get to what defines good. So here I do a little explanation. A good number is going to be the one where after you flip it, right, like this one, actually we can color it so that it stands out. So this one is a good number. because after we flipped it, it gave us a different number than what than what the flipped actually the flipped one is a different one than our original x. X, remember, is here. It's as you're going through all the way to your n. So hopefully now that makes sense. There's a couple of layers in this whole problem, and we're piecing it together. So that's about pretty much the main things to keep in mind. So let's actually go back here so we have a new slate to look at. And this is actually, I mean, when I solve the problem, I write all these comments for myself. So I encourage people doing that. So here, basically, in summary, if basically I thought, all right, I think we're going to have 3 rules that we need to keep in mind. First one is, what are the ones that are just bad? So we were given some rules, and I'll try to keep consistency with coloring. We were given some rules about the 0, 1, 8. All right, those when they flip, they just stay the same. So there's nothing about them. We basically just want to make sure, I think, for those, is that if we have a number that's only made up of those, then that's actually not going to be valid, because you do want, again, you do want your flipped thing to be not the same as what you started with, for it to count. So there's that part. Okay. And then we were given some information about those sort of mirrored ones, the one that becomes one another. So basically, we're given rules about this whole universe. So what's left? Sort of the not so useful ones, really, is we're left with 3, 4, and 7. We don't have a rule about them. All we're told is that basically those would become invalid for those rest. The rest numbers are these, and the whole thing becomes invalid, and therefore you also cannot count it. So once we gathered all these rules, then we could say, okay, what's the first thing I should look for? Well, in my opinion, the first thing is, let me get rid of those invalids, because as soon as I have any invalid number, then I'm not going to be able to count it. And so I want to make sure, as I'm looping through my x from my 1 all the way to n, if any of my x's is invalid, then I'm gonna cross it out, right? So that's this part here, and by crossing it out, it means just continue on with looping to the next x. Now, on the other hand, these ones we could pretty much ignore, because if they exist, fine, they don't make any change, but basically if it's only them, then it's bad. So that really leaves us with ignoring this and really just moving to this section, which really just means, if I don't have an invalid digit, because that's a bigger deal, then I'm in the category of, well, I must have a 2, a 5, a 6, or a 9. Let me see where the 6 and the 9 was here. A 6 and a 9. So that's all you're doing. You're saying, all right, I'm going to check for that. If it does, that's really the only time you're going to finally increment your original counter, which you're returning at the very end. And then how do we get to that? Well, at the very beginning, as we get started, we're just going to go ahead and convert our a little specific x that we're going through, and then we're going to repeat that for all of them, inclusive of n. That's why we have the +1. And that's pretty much it. Then you're just going to be counting and increasing whenever that does happen. Your x has one of these special digits, and that's about it. And here I was just thinking, is there any particular edge case, that maybe it is one of these special numbers, but when you flip it, something is going to happen, but I think it's impossible. So that's about it. That really is the problem set. You're looping through all of your x's and and doing the core logic for each, incrementing as you see stuff, and you don't need to convert back to anything because you're just returning the count. So hopefully that was helpful. As usual, feel free to put any comments or questions or proposed topics within the comment section. And if you like it, subscribe. And until next time, thank you.